In this episode, I wanted to show you the Puppet Labs Firewall module. We're going to use what we learned in episode 8 about Vagrant and Puppet and apply it to managing iptables firewall rules with Puppet. The Puppet Firewall Rules module is well-rounded, seems mature, and is widely deployed, with close to 100,000 downloads. If you have ever had to manually manage iptables rules across many Linux hosts, you will know it gets painful and unwieldy pretty quickly. Let's take a look at an example without Puppet for a minute. Let's assume you have several large clusters: web, app, compute, some database nodes, and potentially many one-off machines. These one-off nodes could be used for internal monitoring, source control, analytics, you name it. But if you wanted to run iptables on each one of these nodes, how would you do it? Well, you would likely have some base or standard iptable script, and then you would have many variations based off your system requirements. It would be a management nightmare, and there is no clear way to verify the rules are running as you expect. On the flip side, with Puppet and the Puppet Labs Firewall module, we can get some relief. In that, it's easy to manage many different iptables firewall configurations, and handling exceptions is a breeze. I'm not going to lie, it took me a while to wrap my head around how Puppet would manage these firewalls, but once I did some testing, it was surprisingly easy and intuitive. Back in episode number 8, which I have linked to in the episode notes below, we looked at configuring a virtual machine running CentOS 6.4 via Vagrant. The reason I'm mentioning this is because we're going to use this exact same setup in this episode. If you're interested in playing around with Puppet at all, I highly recommend watching episode number 8. Okay, let's get on with it. You can use this command to install the module on your Puppet master, but since I'm running Vagrant and a standalone Puppet agent, I'm just going to copy this link and download the tarball using wget on the console. Then I'm going to extract the module and put it into the Puppet modules folder. Let's fire up our editor and have a look. Alright, you can see my Puppet directory hierarchy here. Under the manifest directory, you can see my node definition, and then under the modules directory, you can see the modules listed. You will also notice that the Puppet Labs Firewall module is listed here too. Let's open up the node definition and have a look. So you can see we have 3 blocks that talk about our firewall. The first block purges any existing firewall rules. This essentially wipes the slate clean so that we can add rules with Puppet. The next block uses the Puppet Labs Firewall module, which refers to a custom module called FW. And the FW module has pre and post subclasses. And the logic dependency here is that we run the pre class before we run the post class. Then down here, we call the pre and post subclasses. Let's have a look at the FW module, specifically the pre and post files. Let me just walk you through these files block by block and tell you what is happening. This comment just tells you where the file sits in the directory hierarchy. I mainly added it for you because I added these code snippets to the episode transcript below so that you can copy them if you wish. Next, we define the FW pre subclass. The reason we have pre and post subclasses is that it allows you to specify allow rules in the pre class, and then in the post class you can add your deny rules. Alright, let's talk about the firewall rules now. The first block here allows all incoming ICMP packets, things like ping, to be accepted by this host. You will notice that the top line acts like a comment, and we can control the order in which rules are executed with this 3-digit number. In this case, it's 000. The next block is a rule that accepts all traffic from a local host, along with its comment and 3-digit sequence number. I should mention that these sequence numbers can be the same. It just means that these rules might not be executed in the same order every time. But if you have a lot of general access rules, it might make sense to use the same sequence number, and it kind of acts like a group. This next block here says to accept all related or established connections. Basically, it just means that the kernel will keep track of open connections and allow them. This next rule is a little bit more interesting. Generally, by default, iptables is configured to only block incoming traffic via the input chain. But this rule says accept all related and established connections in the output chain. That's because I've configured this firewall to only allow accepted incoming and outgoing connections. This will make more sense when we review the deny rules in the FW post subclass. So that is basically it for the standard rules. Then down here, since we have rules blocking outgoing connections too, we need to add some specific rules to allow outgoing traffic. This rule says allow outgoing ping. Then this one says allow outgoing DNS lookups. And finally, we allow all outgoing HTTP connections. This is useful for updates and fetching packages. The reason I have a firewall on incoming and outgoing connections is that I feel it improves our security posture. If a rogue application all of a sudden says it wants to talk to the internet, we have to have a rule that specifically allows this traffic. So now that we know about the pre-subclass, let's have a look at the post-subclass. Again, a comment at the top of the file about where this sits in the directory hierarchy. The first block here says to log dropped packets for the input chain. Actually, these three blocks are very similar, in that they all have the same sequence number and they are all performing the same action. That being that they log dropped packets for the input, forward, and output chains. Next, we have three matching rules that drop traffic not matching any earlier rules. You will notice they all have the same sequence number too, and that they are for the input, forward, and output chains. Okay, so now that we know a little bit more about how these firewall rules work, let's have a look at the node definition again. So we're purging the firewall rules, then we use the Puppet Labs Firewall module, which refers to our custom module called FW, and then we call those pre- and post subclasses for the FW module. At this point, you might be wondering where application-specific rules go. Say, for example, where would you add rules to allow SSH on a host, or a subset of hosts? Well, let's have a look at the OpenSSH module here. This is a very basic module using the package file service pattern. You'll notice a firewall block here, but let's come back to that in a second. First, we install SSH. Next, we define a configuration file, and then we make sure SSHD is started. So let's have a look at that firewall block again. It's basically saying allow incoming SSH connections, and the rule is stored within the OpenSSH module itself. What I find so cool about this is that as you assign modules in the host definition, the firewall rules go along with it too. Let's say we have three servers defined in our node definition, server 1, 2, and 3. As we include modules in each node, they will have a service installed, a configuration file updated, and the firewalls are tweaked too. So OpenSSH and HTTPD modules are included for server 2, and as these modules are included, our iptables rules are also included. Server 1 just has OpenSSH installed, so the firewalls for server 1 and server 2 would be different based off the includes. Then up here we defined a standard set of rules which are applied across all machines via our pre- and post subclasses. Before we look at a live demo, let me just show you the HTTPD module for a minute. You'll notice that I use the same package service file pattern and that our firewall rule is in here too. These are very simplified examples, but they help illustrate the power of managing iptables with Puppet. So let's drive this point home with a couple diagrams. We have our site.pp file which holds our node definition, and we define our FW pre and post firewall rules. I think of these as a standard set of rules which get applied globally across all nodes. Then as we include modules in each node, they get tallied up and each node gets a custom firewall. For example, one node might have OpenSSH included, but another might have OpenSSH and a few others. One really cool thing about this system is that as each Puppet agent checks in with the master, the rules are evaluated and updated as needed. So if you needed to add or update a rule to mitigate some type of attack, this could be handled across a large number of machines rather quickly. Okay, enough theory, let's take a look at this in practice. I'm using the Vagrant box from episode 8, the same Vagrant file, but I've updated the Puppet files to include the Puppet Labs Firewall module and the scripts we talked about earlier in this episode, but they're also listed in the episode transcript below. Let's fire up the Vagrant box by running vagrant up. The virtual machine boots and it applies our Puppet scripts. Let's quickly review the output before we connect to this machine. Up here we have the pretty standard output, but then we see our Puppet output, which talks about updating the message of the day file and some tweaks to OpenSSH. Then there's some output about Puppet purging the existing default firewall rules. Then Puppet starts to apply our custom rules. Let's go ahead and connect to the Vagrant box. We can do this by running Vagrant SSH. Then let's sudo to root. So let's see what the firewall rules look like by running iptables -L-N. At a high level, we have 3 iptables chains: input, forward, and output. Then we have some rules for allowing incoming ICMP, all local host traffic, and we allow established or related connections. Then this rule allows incoming SSH connections. Then we log and drop all other traffic. Then for the forward chain, we just log and drop the traffic. Since we have an outgoing firewall too, we needed to have some allow rules for established and related traffic, DNS queries, outgoing HTTPD, and pings. Then we log and drop all other traffic. These log entries typically go to syslog by default, and you'll typically find them in var log messages, but you might want to send them to a specific log file. You will notice up here in the input chain, we have our OpenSSH rule, which is the result of including the Openssh module, but there's no rule for allowing incoming HTTPD. Let's jump back to the node definition and include HTTPD to see what happens. We can use these lines up here to rerun the Puppet agent and update the node. So we told the Puppet agent to run again, using the updated node definition file. The agent picks up that it needs to install HTTPD, and the agent makes sure that it's started, and along with the module, we get our firewall rule. Let's verify this is the case by running iptables -L-N again. And it looks like it's working, since we have the HTTPD and OpenSSH rules. One thing I really love about this module is that it includes these comments in the iptables output. It makes it really handy to see where these rules are coming from. Lastly, let's remove the HTTPD module and see what happens. And then we'll run Puppet again. Notice that Puppet picks up the change and removes our firewall rule. The power this gives you in dealing with hundreds or thousands of machines is really nice. So to bring this full circle, if you need to manage large clusters and many one-off machines, Puppet makes managing iptables firewalls easy. You can also sleep safely knowing that the firewall rules are active and that they're continually being updated as your configuration evolves. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.